Okay, hello everyone. We are discussing application of Fourier transform. So this is the question whatever we are going to discuss today. Okay, so before you are going to start this video, I suggest to all of you that pause the video and try to identify for this question what Fourier transform is going to be applied. Because previously we saw that few questions required Fourier transform only, few questions required Fourier sine transform and Fourier cosine transform. So we already discussed that if here uh, previous class in our previous classes we have been discussed that if in our initial value condition u0t is given, then Fourier sine transform is going to be applied. If del by del x of u 0t is given, then Fourier cosine transform we have to apply. So this is the question for which Fourier sine transform will be applied, that we are going to we have been discussed already. In our last class we have been discussed that here del by del x of u 0t is given one constant, so Fourier cosine transform will be applied for this question, that we have been discussed uh, in detail. So for this question what will be applied, Fourier sine or Fourier sine transform or Fourier transform only or Fourier cosine transform, you just identify, then you start to watch this video. Okay, you just pause for some times and try to identify. Okay. Okay, from this question you can see that initial condition is given that for x equal to 0 u equal to 0. That means if we are going to consider this initial value condition, that means here always we have to remember that u is the function of x and t. So here u equal to 0, that means u x t equal to 0 for x equal to 0. Okay, then t greater than 0, t not equal to 0. Okay, so that means all, or we can write it u0 t equal to 0. So this value has been given. So already we have been discussed that if this value is given, that then what we have to apply, we have to apply Fourier sine transform, right? You can check your note you written previously that if u0t given, then we have to apply Fourier sine transform. So now we have to start to solve this problem step by step. Okay, so let's start. So before to start, here you can see the given equation is del by del t of u, and we have to remember always that u is the function of xt, because here you can see del by del t of u and this side del square by del x square. So obviously u is the function of x and t, and this is the one initial value condition. This is another initial value condition, that u equal to 1 in between 0 to 1 and 0 greater than 1. Okay, and uxt obviously it will be bounded because this u is exist in between this one 0 to 1, so obviously this xt is bounded. Okay, so we have to start to solve it. The given differential equation is, the given differential equation is, here you can see this one, del by del t of u xt, as I told that u is the function of xt, equal to del square by del x square of u, which is the function of xt. Okay, let this is your equation number 1. Let this is your equation number 1, right? As per initial value condition, but as per initial value condition, that is u equal to 0, here u equal to 0 when x equal to 0 and t greater than 0. That means, that implies u0 t equal to 0. So here u0 t equal to 0 given means we have to apply Fourier sine transform on the equation number 1. Therefore we have to apply Fourier sine transform. So in short we can write like this: Fourier sine transform on equation number 1, right? So if we are going to be apply, that means Fourier sine transform will be applied left hand side and right hand side of this equation number 1. So that implies Fourier sine transform is applied left hand side of the equation number 1, that is your del by del t of u, which is the function of xt, equal to Fourier sine transform applied on right hand side of the equation number 1, that is your del square by del x square u, which is the function of xt. Okay. So we have to write, that implies this one will be written as 2 by pi root over 0 to infinity del by del t of u function of xt into sine omega x into dx is equal to Fourier sine transform of double derivative of uxt with respect to x. Okay, keep it as such. We know this value directly we have to write. So that implies, here you can see Fourier sine transform applied over variable x. So and also integration with respect to x. So del by del t can be taken outside. Del by del t of 2 by pi root over 0 to infinity uxt into sine omega x dx equal to Fourier sine transform applied over second derivative, double derivative of uxt with respect to x, or we can del square by del x square of uxt. Okay, so here you can see that this is nothing but this value. Here you can see this value is nothing but Fourier sine transform which is applied on uxt on the variable x. So we can write Fourier sine transform of, instead of x we have to write omega t. This much value we can write this one, already we discussed several times. So same thing we have to write. So del by del t of capital Fs Fourier sine transform, here Fourier sine transform applied over variable x, so instead of x omega t, okay, will be equal to Fourier sine transform of second derivative of uxt will be equal to minus omega square capital Fs omega t plus 2 by pi root over omega into u instead of x 0 t. Okay, because you just recall that we already studied that Fourier sine transform of a function, double derivative of this function which is the function of t, f double derivative of f with f which is the function of t. Okay, or we can write that Fourier sine transform of del square f which is the function of t by del t square is equal to, both are equal, okay, is equal to, we know this one value is minus omega square capital Fs omega plus 2 by pi root over omega into f of 0, small f of 0. Okay, so here you can see that if I will be compare this uxt and this ft, here uxt is the function of x and t, here it is the function of t only, or we can say it is the second derivative with respect to t. This is the second derivative with respect to x. Okay, so here you can see the first term is your minus omega square Fourier sine transform fs omega or Fourier sine transform of ft. This is nothing but Fourier sine transform of ft or fs omega plus 2 by pi root over omega into small f0, small f of 0. So here plus 2 by pi root over is there, omega. So here you can see that derivative with respect to x. So instead of x we have to put 0. Here derivative with respect to t. So f of 0 instead of t written as 0. So instead of x we have to write 0 here. Okay. Okay. Now let us consider this is your equation number 2. This is your equation number 2. Okay. But from initial value condition we have that u 0 t equal to 0, right? U 0 t equal to 0, one of the initial value condition, or initial value condition 1 is nothing but 0, u 0 t equal to 0. So this term will be 0. Okay, but from initial value condition I, we have u 0 t equal to 0. So that implies the equation number 2 will be, that implies del by del t of capital Fs omega t will be equal to minus omega square Fs omega t. Okay, let this is your equation number, let this is your equation number 3. Let this is your equation number 3. Here you can see that the equation number 3 is a simple first order differential equation. So solution of this equation number 3 will be, the solution of equation number 3 will be capital Fs omega t will be equal to capital A, which is the function of omega. You can write or you can ignore itself, only A into e to the power minus omega square into t, minus omega square t. Let this is your equation number 4. Let this is your equation number 4. See, we know how to solve this type of differential equation. Suppose we have del by del t x, del suppose like this, del x by del t equal to minus some constant c and x is there. So how we are going to solve it? You just take x over here, del t over here. So del x by x equal to minus ct. So this will be ln x equal to if I am going to put integration, this is the dt. Okay, so integration, so minus c dt plus some constant ln some constant suppose. So here ln x by a will be equal to minus ct and x equal to a into e to the minus ct. Okay, so instead of constant c, here it is omega square is there. Okay, so instead of x we have capital Fs omega t. So obviously this this is the solution of this equation number 3. Okay, so just put it in the box. Now in this equation number 4, a omega is the constant. Okay, the constant a omega will be evaluated by using second boundary condition. Second, using given second boundary, or you can say initial condition. So what is the second boundary or initial condition? Is this one, u x t equal to this much at t equal to 0. So this boundary condition we have to apply to find out this constant a omega. Okay, so the second boundary condition or initial value condition is uxt equal to 1 within 0 to 1, x value 0 to 1 and 0, uxt will be 0 when x greater than 1, but these two values will be possible for t equal to 0. Okay, or we can write here like this, u 0 sorry x 0 will be 1 when x in between 0 to 1, 0 when x greater than 1. Okay, now to find the constant value a omega, this one we have to apply again Fourier sine transform on this second boundary condition. In short, I have been written second boundary condition BC. Okay, we get here, you can see Fourier sine transform applied over this uxt. Normally we can write 2 by pi root over 0 to infinity uxt sine omega x dx, that we know, right? So here, if we are going to consider this boundary condition, then we have to consider t equal to 0. Okay, so t equal to 0. For that, in between 0 to 1, u 0t. See, if I will put 0 over here, then it will be written as, sorry, x0. Okay, x0. So u x0 value will be 1 in between 0 to 1, 0 above 1. So I am going to segregate this integration 0 to infinity, that 0 to 1 u x0, because for t equal to 0. Okay, x0 sine omega x dx plus 1 to infinity u x0 sine omega x dx. But for x greater than 1, u x0 value is 0, so this whole term will be 0, and we are going to get 2 by pi root over 0 to 1. Here u x0 in between 0 to 1, the value is 1. Okay, the value is 1, so we have to put u x0 in between 0 to 1 will be 1, so only sine omega x dx. Okay, implies that fs omega u x0 you have to write always, so implies that fs omega 0 will be equal to 2 by pi root over, and the integration of sine omega x will be minus cos omega x by omega 0 to 1 limit. Okay, so this value will be 2 by pi root over minus omega cos omega plus 1, because see here minus is there, and if I am going to put the limit, this will be cos omega minus put 0 value will be 1, cos 0 will be 1, so minus will be, minus is already there, so minus cos omega plus 1, so minus cos omega plus 1. So you can write fs omega 0 equal to 2 by pi root over, put the 1 initial at initial, so 1 minus cos omega by omega. Let this is your equation number 5, right? From equation number 4 also we can found fs omega 0. See, equation number 4 represents this one. If I will put t equal to 0 value, so here this will be e to the power 0, that means 1, and we can get fs omega 0 will be equal to a omega, right? From equation number 4, fs omega 0 will be equal to a omega for t equal to 0. Let this is your equation number 6. Now you are going to compare equation number 6 and equation number 5. Equation number 6 and equation number 5, if I am going to compare, then I am going to find out that a omega value, see here left hand side fs omega 0 is there, fs omega 0 is there. So obviously a omega value will be equal to this much, 2 by pi root over 1 minus cos omega by omega, right? Same thing it has been written. By comparing 5 and 6, we get a omega equal to this much, right? Now we have to put this a omega value in equation number 3. Okay, so equation number 3, no, equation number 4. In equation number 4, we have to put in equation number 4. Just correct it. In equation number 4. Okay, put a omega value in equation number 4, we get. So in equation number 4, if we are going to put a omega, will be this, we can get this one, fs omega t will be here. Instead of a omega, we have to put this value, 2 by pi root over 1 minus cos omega by omega into e to the power minus omega square t. It is already there. And this equation number 4 is nothing but your general solution of this equation number 3. So by using second boundary condition, we found a omega is this much, and we just substituted, and the equation number 4 we got this one. This is your equation number 7, right? Now to find out the general solution of given differential equation, see, we intend to find out, our objective to find out the general solution of this equation. Okay, so this equation general solution is your small u, which is the function of xt. So how we are going to find out? Carefully you have to watch here. Whenever we have been applied Fourier transform, whenever we have been applied Fourier sine transform over this uxt, we found fs omega t. So now if I am going to apply inverse Fourier sine transform on this fs omega t, so obviously I will get the the initial value, initial one, that is your uxt. You got it? If I am going to apply the, like this, you have to write, it will be better. So I applied Fourier sine transform and I found fs omega t, right? Whenever I will apply inverse Fourier sine transform on this, then I will be, again I am going to get the small uxt. So here you can see that in your equation number 7, capital Fs omega t is there. So if I am going to apply inverse Fourier sine transform over this, then I am going to get the small uxt. We have to do so to find the general solution of given differential equation. That means in your question, apply inverse Fourier sine transform on equation number 7, this one. So left hand side we have to apply inverse Fourier sine transform over this one, inverse Fourier transform over this whole function, right? Same thing, it has been written 2 by pi root over 1 minus cos omega by omega e to the minus omega square t. Okay, so inverse Fourier sine transform, whenever it will be applied on this, it will be small uxt, right? So then inverse Fourier transform, whenever is going to be applied on a function, this will be written as 2 by pi. You just recall that see, whenever we have a, suppose we have a function fx, okay? So if I am going to apply Fourier sine transform on this, it will be written as 2 by pi root over 0 to infinity fx into sine omega x dx, and this is nothing but written as fs cap small omega will be 2 by pi root over 0 to infinity fx into sine omega x dx. And whenever we are going to apply inverse Fourier transform over this, that means inverse Fourier sine transform, if I am going to apply fs omega, this will be written as how much? 2 by pi root over 0 to infinity, this one, capital Fs omega into sine omega x into d omega. Okay, so here omega and this function, which is the function we have to consider, that is also this fs. Fs is the function with the function of omega. So omega here x is there. So this is nothing but inverse Fourier transform of fs omega is nothing but the original function fx will be this one. So these things already we know. So here we have a function which is the function of omega, already is there. So this one, okay, if I will apply Fourier inverse transform, then what it will be? 2 by pi root over c, 2 by pi root over 0 to infinity, see 0 to infinity, this function into sine omega x into d omega. So this function, entire function written over here into sine omega x into d omega. So that implies uxt, small uxt, the required general solution of the given differential equation in your question will be equal to 2 pi by root over 2 by pi root over, it will be 2 by pi equal to 0 to infinity. This will 1 minus cos omega by omega into e to the minus omega square t into sine omega x into d omega. So this is the required solution of the given differential equation. So I suggest watch carefully, write down the note. If you got any doubt, comment in your comment section. Okay, thank you so much for watching this video. Thank you.